Okay, so we're just going to pick up where we left off last week. So, as a reminder, we're going to load in the packages that we're going to use in today's session, or the ones that we were using in last week's session, which is the read Excel package, tidyverse, ggpubr, and the R color brewer for certain palettes. And just as a reminder, it's very important to set our working directory to where our files are located or where you want to store or save your outputs. Next is to use our read Excel to get the Excel sheet and the Excel file and the sheet that contains our information, assigning that as assay. And then we're going to change our reps to factors. We're going to change our treatments to factors, soil and year as factors as well. Last week we also touched on pivot longer. And so we had created a new data frame where we pivoted the columns, total root rod index, AF root rod index, and rise root rod index into a new column with the name root rod index type and the values to a new column titled index value. And this really just allows us to compare those different treatments side by side. And it really helps organize your data a little bit better. So like I mentioned, we're going to kind of pick up where we left off. Last week we had, the last thing we did was create a bar plot, a GG bar plot with our assay long data. And one thing that we can do with GG bar plot now, so let me kind of see where I left off here. So what I was kind of mentioning last time was taking note of the minor differences when setting up this type of plot compared to using ggplot2. And if you need help with anything, remember that you can always highlight and click F1. And that will bring up all of your options and everything in your help tab to help you know what else you can do to this plot. Okay. So one thing that I really like about GG bar plot is that you can also add labels. So I'm just going to go ahead. We're going to do that right on top of this one that we created last week. So is everybody kind of at this point? And so here, if we go to once again, highlight, click F1, we go to this help panel and we can see here we have some options for labels. It's easy enough. So we're gonna have to go into the GG bar plot function. So it's gonna be above the scale fill brewer or anything like that. I'll just kind of pop it in there. So once again, we have to be within the GG bar plot parentheses, our main parentheses there. And we're just gonna do label equals true. Attempt at.
You have an additional plus sign.
Where? Oh, thanks. And that's exactly why that wasn't working. Now that looks pretty messy. I don't know about you guys if you're seeing the same thing. Oh, we can do a couple other things here. So we're also going to change the lab, so label, number, digit. Let's just do them on whole numbers. So we're just going to do 0. And there's a few other ones that we can add here. I'm just going to off that because that's where we're working. So we're really just doing these labels right now and kind of showing. We can also change the label size and we make it much smaller. See what that does. Oops, I need a comma. Very, very small. Ooh. Yeah,
object true is not found.
Label equal true?
Yep.
Do you have it within the correct area?
Yep. Right after position.
Do you have a comma?
True. Oh,
yeah.
For two,
yeah, it has all case sensitive.
Yeah, no, capitalized true is not found.
Are you spelling true?
Oh, no,
right?
No, it has to be all capitals.
Yeah. So as Mike was finding out, when you're using these arguments, true and false have to be all capital letters for it to work. So once again, here's just kind of the general or some other additional things. So we can add in labels We can change the number of digits, we can change the label size, and we can also change the vertical adjustment. So if we wanted to, we could do lab vjust equals, I think it's -2 actually goes up.
Is this supposed to be lab or
Oh,
LAB?
yeah, here, LAB, here. I did the lab. So yeah, negative, if you do negative, it's actually gonna bring it up higher. If we just do a +2, it's gonna bring them down lower inside of our things there. Now, unfortunately, I don't know how to address, you see that some of them have now been cut off because they're either too low or too high. We can do some things where we're changing our axes to go a little bit higher. That way we can get those ones that are kind of cut off on the top. Actually, let's just see if I can do that. Scale Y continuous. Oh, I always forget how to do this. Limit. Oh, maybe we can just do that. I think we can just do Y limits 0 and 20. Aha. Okay, so that's easy enough. So like I said, we kind of were cutting off some of those ones. I'm going to do -2. I'm going to make them a little bit bigger now too, just so you can kind of see. But the only -2. There we go. Essentially what I'm doing is I want to have my labels up out of the columns there, right? So floating on top. However, my Y axis was cut off at 100. So we can just quickly fix that by just saying our Y limit is just 0 to 120. And that way it will bring that scale just a little bit higher there. So you can see within there. We can also do some other changes. I guess, yeah, now is a good time we can do it. I need help with this one. I think we have to do now something different. So just bear with me. Scale Y. Since these are numbers, this is continuous, right? So discrete would be like I have group 1, group 2, and group 3, where continuous is just I have a scale from 0 to 100. It can be anything within there. So scale Y continuous. We're gonna do I think we can do break equal 0, 75. I'm just doing this as an example. Let's see if this works. Oh, that didn't work. I think maybe we also have to make 0. Oh, maybe so once again, this is kind of what I always do. Oh, that's why I need my C, my combine argument. And I'm just going to see if that works without doing. I guess it's cut off there. Let's see if these work together. Sorry, I'm just kind of playing around at this point, so sorry. So I think what's happening here, if you end up doing this and you set your Y limit, it will do that, but then it's overwriting it with scale Y continuous. Let's see if I can do Y limit in here. Cannot coerce. Okay. Okay, I just wanted to try some stuff. So it's either or, right? So you can kind of change your breaks. There's a lot more you can do with scale Y continuous. I guess I'm not going to go into that right now. I'm not feeling too comfortable with it. So anyways, that's just kind of what we can do with ggbarplot. We can add in different labels. We can add mean standard error or mean standard deviation if that's what you would prefer for your error bars. It's kind of nice. You get a good representation. So I like to use this mainly for like extension talks where a lot of the people just like to see the numbers and the bars, right? Whereas the GG box plot, you're really able to see the distribution of data. And so maybe that's more appropriate for some scientific posters or talks as well. Okay, I'm gonna keep going down. Is everybody okay with this right now? I think that's really where I want to stop at. And now I want to introduce the jitter function. So like I mentioned, you know, we might be wanting to do a box plot that actually shows all of our distribution. So I'm going to start a new chunk here, and I'll just label that box plot with jitter. And we're going to use the GG box plot. This time we're only going to use our assay. We don't need to use everything else here. So just as an example, X will do, let's do treatment. Y is, and let's just look at AF root rod index. And fill equals treatment, get some color on there. And finally, so, you know, the last few times we've been adding mean SE. Now we can do both, but we're just going to focus on jitter this time. So we're just going to do jitter. Let's just see what that looks like. Perfect. So essentially what this is showing you is all of the individual data points across both soils and both years. So if we want to change that, this is an odd argument. We're going to do add parameters, and then you have to do this list. I don't get it. We're going to do shape equals, we'll do soil. Maybe I'm gonna, yeah, let's just do that. Okay, close all that. So I guess it's a little hard to see. So you can see now that like the circles, actually, sorry, I will zoom in. Sorry, there you guys go. Now we can see a little bit better. So now all of the triangles are the pearly soil, all the circles are the climax. So once again, you can really start to see that distribution of data and how these are added in. But like I said, those shapes are kind of hard to see. So there's another thing we can do. You know, so we can add in a lot of these other ggplot. So we're going to say scale shape manual. Now this is going to change our shape adjustment. So we're going to just do 2 and 3. I think these ones make them hollow. Oops. There we go. That is an odd shape. What is? Sorry, I'm just going upwards, downward triangle. I don't know. I regret to inform you. I do not know where to find all of these values, right? So I'm just saying shape number 2 and shape number 6. I think if we look online, we can do like scale shape manual, ggplot, images. Yeah, there's like 20 shapes. So it's something like, all right, so I think it's something like this where shape number 0 is a square, 1 is a circle, 2 is a triangle, so on and so forth. Is it the black one? Yeah, okay, so that's the one then. So all of those are your options. Do 11.
11 and 15.
Sure. Anyways, yeah, you have options, right? I am just curious. I'm just going to try this. And now there should be 4. Darn. Fine. So it's not really letting me do that. So I guess we can only assign 1. But we could also do, let's see if this, we're going to change fill to soil. And we're going to say, oh, I'm just seeing if this works. So at this point, I'm just kind of playing along. You guys can see kind of what I do to try to make things work. Yeah. No. Oh yeah, that works.
Quick question. So the order of the variables under your plot, does that matter? And sorry if this is like, if I'm asking this and this has been covered before.
The order on our variables in our plot.
Yeah, like
You
when
mean
you
like right
enter
here, like
your
this
like
Gabin and Tachagaran one?
actually like in the code itself, when you list it like X, Y, fill, add, all of this.
Oh yeah. So as
Um,
long all of this stuff, no, I mean you can do it any order that you want. Essentially, what's happening when you do this parenthesis and close it out, it's all happening at once.
mhm.
So
Oh,
once
okay.
yeah, so it doesn't matter. I can put my add on top here. I can put my Y. I'll just change that around. Right. It's still going to do the same exact thing. So nothing's going to change there. Now, what you do have to be careful of is once you close out and you start adding these pluses, then you do have to be mindful of your order because you can overwrite certain things.
I see. Okay. Mm-hmm.
Right. So I can do the same exact thing. I'm going to do scale, shape, manual again. Values.
Oh, manual.
What was your favorite one? 15 and 16.
Oh,
Oh.
manual might not
Thank you. Man, you will. So essentially what that does is say scale for shape is already present. Adding another scale will replace the existing one. So that's where you have to be careful of adding these pluses because you just overwrite certain stuff.
I see. Uh-huh. That makes sense.
Yeah.
Uh-huh.
Cool. That's kind of what I want to show this jitter. Jitter is a really nice thing to show distribution. For example, I guess I don't. I just recently had a poster where I had 400 different isolates, right? And so when you have that amount of data, you really want to see that distribution. And another way you can actually see distribution, I'm just going to do this. We're going to copy and except for that. And the only thing we're going to change here is ggviolin. So now that kind of shows us, so these are kind of like box plots in a way. It's trying to show you that distribution of data, right? And so we kind of have, clusters here. So ggviolin, I don't really like the look of them. Some people do. But once again, it's just another way to convey the distribution of your data.
There's GG.
Violin. So these are called violin plots. Okay. That answered your question, right, Heidi?
Oh, sorry, I was on mute. Yes. Yeah, thank you.
Okay, perfect. Oops, sorry. Okay. Okay, now finally my favorite. I do a lot of time series stuff. So this one's going to be a little bit more difficult. We got to pull up our pivot longer again. So I would like to create a line graph with GG line. And then really, once again, this is to display trends or patterns over time. So we're first going to need to create a new data frame. And we're going to call this one assay. I will just call it plants for plant stand. We're going to do pivot longer again. Sorry, this is going to take a little bit of time. We're going to take from our assay, our original assay data frame. We're going to take our columns labeled days after planting 6, days after planting 14, days after planting 21, days after planting 28. And once again, this is what I do. Now I'll go in and add those. I'm so sorry if it's hard for you guys to follow along like that, but
It really doesn't matter if it's double quoted or single quoted.
nope, not at all.
What's the hotkey that you use?
Should be. Okay.
I just highlight, I just double click and then click, and it automatically does it. So if I highlight anything and just click the thing once, it will do it. So that's what I like doing.
Miss what?
Yeah, I think Sam said something else though.
I like just doing shit.
Actually doing it as is. Yeah. Let's keep it the way I have it and plant. Okay. Essentially, once again, this is taking all of our days, like for everything on 6 days after planting, 14, 21, 28. We're combining that all into one column named days after planting. And then values to plants. We can call it plant stand, percent plants. I don't care. I'm just gonna call it plants. So if we run that, you see we have a new thing here, assay long, or assay plant, sorry, assay plant. Where all of our days after planting are now in a column and all of our plant stands are in a column. Now this might look a little funny and it will help as we move forward if we do assay plants. We make this an ordered factor. Assay plants, days after planting. And we are going to overwrite that. Oops, I'm so sorry. Ordered assay. And once again, I do a lot of copy and pasting to make sure that I have it right. And then we're going to take our levels equal. Once again, I do a lot of copy and pasting. It just helps us out. I want that same exact thing there. So those are our levels. We just created it. And I want to make the new labels just the numbers. So 6, 14, 21, 28. Whoops. And close it all out. Okay. So now we can see in here, we have days after planting as an ordered factor with 4 levels going from 6, 14, 21 to 28. So sorry, can you guys still see that okay? Do you need me to? Also, while you guys are doing that, I want to take a quick moment just to acknowledge. It's very nice to see that some of you guys have been putting this into practice. So yeah, Lindsay, good job. And James, very good job.
I read some of my data in and made a box plot with it. Yeah.
Yeah, James ended up summarizing 2 years of data from a field trial, made a couple of plots. And
I mean, honestly, after seeing how easy it was to make the plots in Jump, like they actually made it kind of not in Jump in R, it made it kind of painful to go into Jump and to like just be there.
Yeah. So, on that note, yeah. So, Lindsay is just talking about how, having to manually do everything like in Excel, right? So that's what I hated. I'm like, oh, I want to change my line type. You have to go into every individual one and change your line type. Now, what if you wanted to do that for different treatments or different years? You have to do that multiple times, right? And so with this, it's as simple as changing one line of code, right? And then you can copy and paste that code to do it for your other figures. So they're all very uniform. They all look identical. They're all the same size. And I would also just like to add that, the reason I prefer R is because it's like a one-stop shop, right? If I needed to do any data manipulation or do any formulas, like estimating recoverable sucrose per yield, or even, adjusting grain moisture for 3.5%. You don't have to do that in Excel. You can bring your raw data in. You can make all your formulations there. You can then subset your data between different years. You don't have to have 5 different Excel sheets for everything that you have. You can then do all of your statistics. You can make all of your summary tables, and you can make all of your figures all in one spot. And once you get comfortable enough, like I said, then you can carry that through and maintain consistency with everything you're doing. So all 15 of my trials all have the same output. They have the summary statistics, they have the tables, they have everything they want, they have all the same figures. So there's no like, well, why is this one different, right? So consistency and, you know, having a one-stop shop. So that's kind of why I like it. Anyway, so is everybody good? Does everybody have this GG or this pivot longer, this new assay plant? Okay, I see a couple heads nodding. Now we can finally, we're gonna make a new chunk and we're gonna do GG line this time. We're gonna go from our assay plant data. X is actually gonna be our days after planting. Y will be our plant. Those are the ones that we just created. And we are going to color by treatment. Just be mindful, since these are lines, there's no fill. So fill is null and void. All right. So as you can see, this looks a little funny, right? It's trying to plot out all of our data points. So with GG line, you also need to add mean. You can just do mean or mean standard error or any of those other ones. I'm going to add on mean standard error so we get some error bars. Now, would anybody like to speculate why the Tachagaran seems to be having better stands? James?
You did just speculation.
Is there maybe like a pathogen in that soil that Tachagaran controls, but Kabina doesn't?
You still have it?
Yeah.
I'm
Yeah.
So that add rise did
Oh, add what now?
add equals mean rise.
Mean rise. What are you talking about?
Oh.
Oh, so sorry. I'm so sorry.
I was like, mine is not looking like yours.
Did that actually work though? Mean rise?
No,
No.
it didn't throw an error, it just didn't change it.
Oh, okay.
Okay, so there's one other thing too, with line graphs, you can do this plot type. B stands for both line and dot. You get that circle there. If I just did L, it's only gonna do the line. It's not gonna add that little dot on there. So sometimes it gets cluttered. I don't know if you really want that. And I think there is one more where you can just get, that doesn't make sense, but I think you can do just point. Right? So if you don't want the lines, I don't know, it kind of defeats the purpose of a line graph, but you can do that. So anyways, I think B, the both is the,
Has to do with salt.
What?
To be in a salt con.
no. No, these are soils infested with the Phanomyces. And so a Phanomyces and an oomycete, Kabina does not control a Phanomyces. So when Kabina is here, all the plants are dying off very rapidly. When Kabina is added to seed treatment, it's protecting against that root rot pathogen. However, by 3 weeks after planting, or even you can see,
Tachagari, that's good.
Tachagaran is protecting plant stands.
Yeah.
Right? Is that not what I said?
Wow.
Kabina does not protect against the Phanomyces, so they die faster. But with the way that we do this, they're very wet and humid and very conducive environments. So those seed treatments really don't last long anyways. Really, this is just these trials are just for us to verify that yes, the Phanomyces is indeed in the soil, to test varieties and other things. Okay, what else can we do? Okay, so we can change the plot type. We have B for both point and line. We can also change our point size. Oops, yeah, point size. Let's make it incredibly large. Let's see what happens. Okay, that looks odd. But you can do this. Maybe I'll make go 1.2. When you're blowing these up for presentations, those points can get very small. So just as an example, if I copied this and I did my, whatever. Those points and lines stay the same size. Everything like all of your letters and things stay maybe at like a 12-point font or that size, and the figure just gets bigger around it. So that's why it's important to change plot sizes depending on if it's going to a paper or anything else. So the last thing that we can do is, technically looking at the bottom here, we have 6, 14, 21, 28, but those are not equal distances apart because it's not being read as numeric. Right now, those bottom points are being read as discrete groups, right? So they're factors because we made it an order factor. So we can do this numeric x-axis, all capital letters, true, and for the most part, maybe it just doesn't want to do this right now, but if we had more data on the bottom, it would make those equal distances apart.
So why sometimes do you do an underscore and other times you do a dot?
I don't know. So once again, so Mike's question was, well, why do some of these have an underscore for plot type and some are just a dot point size? I really don't know why, but just keep in mind, that you can always go to the help here and figure out which ones you want to use. Right? Facet by. Yeah, I really don't know. Darn, okay. Curious. And I think like it looks like theme classic is kind of what this uses all the time. Is everybody comfortable with like using the theme again? So if I went back, changing the text, we did in a previous session, we did go into that in detail where you can change all of your size, color of your text. That was the first graph that we made with all the different colors and everything. Would you guys like me to bring that back up?
You just copy and paste it, don't you?
Yeah, exactly. You can just copy and paste it. So yeah, let's do it. I have a bunch. I'm so sorry. I have it all right here. So once again, just to kind of emphasize, within theme, we can change our text, different sizes, colors. We can change our axis text with, let's say we want to put that at 90 degrees. Adjust that. We can put our legend on the bottom. Oh, and this is also very important, I will say. So this legend key width. So a lot of times with line graphs, our line here, especially if you're doing like line types where you have like dot dashes or dash lines, our legends aren't long enough to accurately identify what line belongs to which. So with this legend key width, we can extend that out to make it longer so you can see those specific things. So I'm actually going to do that right now. I'm going to change this to shape. So you guys can see. Shape. Oh, whoops, not line. Line type, that's what I. Okay, see how we have like solid and dashed. So if I had this like really, really short, if I had our legend key short, then a lot of times we can't identify like the dot, dash, dot type lines. So that's where I added just a longer key width. That way you can actually visualize that. So that's actually probably pretty important. I don't know about journal requirements for you, Lindsay, but color is more expensive. So using line type and shapes. So I can also do that too, where I'll just do shape equals treatment. Oops. Okay, and then I usually should. So now our points here are circles and Tachigarn's triangles. So now we can have combinations of, triangles and dot dash lines or circles and solid lines, so on and so forth. The limit's probably like 10. It gets really hard to see after that. Even with like 5, 6, 7 treatments, it's hard to identify the differences sometimes. So once again, all we did there, instead of using color, we're using line type and shape. And then that directly ties in with this plot type too. So if I ended up having this as a line, our shape really doesn't make a difference because we're not putting in that point. And vice versa, if we did just, point, now our shapes have no meaning, or our line types have no meaning. those ones are very important. You know, once again, just for the fun of it, I'm also going to add in our facet by so we can see the different years. Year. Perfect. You want to speculate on why we see lower stands in the Tachagaran treatment in 2023 compared to the Kabina treatment? What does rhizoctonia do? Very, very, very early on. Causes pre-emergence damping off. So vice versa, we have more we potentially have more rhizoctonia in the soil, suggesting that.
How do you have information from 2024?
We just did this last week, 2 weeks ago. Yeah. I mean, I say we. James did it.
The greenhouse is empty.
Yeah, but that's for our growth chamber.
Oh,
And our greenhouse just had stuff put in it this morning.
really?
Yeah, rhizoc inoculum. Okay, let's what are we? 10:45. Okay, let's just do this scatter plot really quick, and then we can take a quick break because I've had a lot of coffee. Okay, so GG scatter. These are really good for displaying the relationship between certain things. And also with this, you can easily get all of your like the correlation coefficients and the p-values as well. So like I said, ggpubr is a very powerful package that can even do statistics for you. I'm not really good with it, but you know, they can create your groupings. So if you had bar charts, they can create your p-values and groupings and things like that. I don't really like the look of it. So, you know, I might do some adjustments later on for those types of things. So we are going to do a GG scatter. And this time, let's what am I doing here? Let's just go ahead. We'll take from our plants data. We'll see if there's a relationship between rhizoc and Aphanomyces root run index. That's what I have here. So I think I did a couple different ones and there was some really weird correlations. But really, this isn't the best data to be doing this, and there's not a lot of data points. Usually what I'm doing here is like, let's say I have our stand count or population data for, you know, 200 different plots. And then we also have our disease rating. So you'd assume maybe with denser stands, you'd have higher amounts of disease. So is that true? You know, so these are those correlations that I usually do. Or, you know, is there a direct correlation between disease severity and our final yield, right? So if I have a very linear relationship, I am confident, or I have more confidence in knowing that the disease is what's causing our drop in yield and not some other environmental impact, right? So yeah, there's things that you can do here. So this is just an example. So we're doing assay, plants, X, Y, and finally, all we have to do is add or just do this reg line. Oh, sorry, I'm lying. Add again, reg line, so regression line. Let's see what that looks like. Aha, okay. So that's the regression line is added just by using that add. But let's say we want some confidence interval type stuff. So we can add in confidence interval, all capital letter, true. Sorry, right. That kind of gives you that buffer zone of like what could be happening. There's also this, sorry, I'm gonna go back and forth. I think you can do this, Lois. Okay, so this is like a smooth local regression, right? So it's just trying to show you the best fit between all the treatments. So you can kind of see certain drops there. I'm gonna be honest, I was hoping Yoka would be here. I'm like, when do you actually use this like local estimate? It just looks bad.
Yeah, I mean, well, I guess my question, and this is not gonna be a question you can answer, but like usually with the low smoother, they also have like a lambda value that you can set with it, like a width, like
Sure.
So,
I don't, with GG scatter, I think you're kind of limited because it's doing its own thing in the background.
yeah, I think it's like usually I've read about using it when like you have a data set that you need to basically turn into a different data set. Like it's
Like weird transformations and things.
yeah, if you have this interaction between alpha, like
Yeah.
alpha Phantomyces and Rhizoctonia root rot that you have to turn into its own variable, then a little smoother would be.
Weird.
It's complicated.
Yeah, no kidding.
I would
Okay, well anyways, let's just continue on with the regression line. You know, that's typically what people will be using to find if there's a true correlation between some things. We can also, from here, add our correlation coefficient, and all we have to do is just say true. Now that's gonna add our R value and our significance level. So this is very, very significant, less than 0.00000001. And our R value is negative 0.73. So the more rhizoctonia that we have, the less Phantomyces we have, essentially, which is kind of neat.
Let's change the position of the R value.
Yeah, I'll get right into that. Wait, is it kind of hidden? Wait, you already did that? Actually, I don't even think I did that on this one.
I don't remember. Position x-axis.
I don't know if we actually can with this one. Let me just see. GG scatter.
So what are you looking for?
Coefficient, core coefficient ordinates.
Okay.
So I want to put it, we'll move it out. Yeah, well, yeah, for mine. This x-axis will be 60 and y-axis will be 75. Oh, went too far over. Let's go 50.
Argument 3 is. Oh,
And lastly, I'm just gonna add for method. All right, so we can do a couple different ones.
you have to switch your thing back to viewer.
You're gonna want to be in plots.
You do have to.
No, not necessarily. Sometimes it should pop up. But there's some other options here. So you can do your method of correlation. You can add in your Pearson's correlation. You can do a Spearman correlation or this Kendall correlation. Let's just change this to Spearman, see if anything changes. Right, so my R value is a little bit lower. I don't like that. I'm gonna go back with the Pearson. But anyway, so those are those options, right? And also, yeah, if you want to change the size of this, we can also do core coefficient size equals, let's make it super tiny. What? That got bigger. 2. There. Right, so those are your options within ggpubr. So once again, I just really like this package. It makes making scatter plots and things a lot easier.
When you put equals true, this is kind of, I have like general type questions, but like when you put equals true, is it kind of like adding something?
Yeah, so exactly this coefficient interval true added the gray buffers around the line. So without this, if I did false, oops, it takes away that buffer, right? But yeah, it's just adding stuff within the GG scatter arguments, right? So we're not doing anything after with that plus sign yet. Same thing, the coefficient is the numbers here. Oops, the numbers over here. If I didn't want that being shown, I'll do false.
Okay, so when you first add something like that, that regression line, and then, you know, your arguments with under that, then
Yes.
okay, you want that true, that true. Okay, I see.
Yeah,
Kind of the
so if
structure of
we
it.
kind of going into it, so if we go into help again, like let's go to coefficient, yeah, logical value. If true, correlation coefficient with p-value will be added to the plot, right? So once again, if you go through these, it really kind of helps you. But what am I trying to say? The what is it called? When something, I'll explain. Like the automatic settings, I guess, are just not to have it, right? So the automatic settings are already false. So in the background, when you're running this and you don't explicitly state it, it's reading it as false, right? So we just have to then explicitly say, no, I want that as true.
Oh, okay, yep. Yeah.
Huh? Yeah. This one, the coefficient is the numbers, the p-value and the coefficient value. The interval, coefficient interval is the shadow.
So they know that something that's false, so they show up. So if you want them to be.
Yes. Yeah. The automatic setting would be false, or you're assuming that it's reading as false. So, this is nice. This is for overall data, but I want to look at all my individual treatments, right? Like, well, is there a difference between the Kabina versus Tachagaran, right? So we can also look into that. We're going to do, we can copy and paste most of this, actually. So let's go ahead. And we're going to copy and paste just that top portion. And then we're just going to add in here color equals treatment. Oops, treatment. See what that looks like. There. So once again, now we're saying, oh, separate it between different treatments based on color. We're still going to add our regression line, and we're still going to add in our confidence interval. Now, the thing is, if we ended up using these arguments where we had correlation coefficient true, it's only going to add the 1 from the previous figure. We would need to write or get a different coefficient for each treatment. So with that, now we're finally going to do our plus sign, and we're going to bring in the stat 4. And this is still through ggpubr, right? So this is just an area where we can do a lot more with our correlation coefficients and things. And it's going to operate very similar to ggplot. So we have to send in our aesthetics, matching up with the top one, saying color is treatment. Okay, we're also going to change or keep our method as Pearson because we want the same correlation coefficients. And let's just do digits equals 3. Let's not even do that. Let's just see what happens. There. Now you can see now we have a correlation coefficient for each treatment, right? So we have 1 for Kabina and 1 for Tachagaran.
That is false. I don't.
Stat plus, you have plus stat core aesthetics. And then close out, make sure that method is not in aesthetics.
So I had quotation.
No, it is.
You did not have quotation.
Actually did the same thing. Mine too.
Oh, with
Why
the
is-
treatment?
Why is that meant?
Well, because we're using the stat core package, and it operates very similar to ggplot2. Remember when our very first figure we made in ggplot2, we did not use quotations around our variable names, which can also cause a lot of problems.
Yeah.
So that's something like if I had this as, I'm actually really curious. Oh no, I don't have it that way. So if I had this, if this started with a number, so let's say it was 6 days after planting. So I had 6 days after planting. We couldn't use that. One, there's a space in there and it starts with a number. So that's exactly why we don't use stuff like that. Always start. That's why if you see, I had days after planting 6. Not found. Assay plants. Yeah. Well, now that you said, I'm just curious. Yeah, I don't. I'm just messing with it. There's no doesn't know what to do with that. Anyways, there's some other stuff we can also add in digits. So if we want to add it, make our correlation coefficient, one more digit longer, we can do that. And also change our label. So we're going to move it. So this one, we're going to do label X. So our label is moving on our X axis, and we're going to go out to, let's say 40. Right? Then the start of it is now lined up with 40.
So you told it to have digits equals 3, but we only changed it to
Yeah, so you can assume that this one would be 0.400.
but it should still be similar.
No, because the way it rounds is weird when it does that. There we go.
But wouldn't that like be inappropriate in a chart then?
It is weird. Even like, I don't know if things have changed, but like Lindsay was doing this in a class the other year. And like, they don't like you to do that anymore. So like, if you're rounding things, they want you to do your nearest whole number. So that should technically just be 0.4 and not 3.99 or 4.00. So it's just like redundant numbers. It threw me for a loop. I was very confused. So I don't really.
Wait, okay.
I know. Things they teach nowadays.
Yeah, I mean.
Welcome to the party, Sam.
Hello. On break.
We're just about doing it right now. Yeah, so that's exactly where I wanted to leave off. So good.
Asking questions.
Yeah. Okay, so this is perfect timing. That's really what I wanted to get at, is kind of showing what we can do with these maybe a little bit too much information. So I don't know if I'll get to it, but there's a way, we were talking about making or transforming data. So there was one time I had it where we had some really bad issues with, like, let's say stand. And I wanted to do an estimated means if stand was equivalent, right? Because we clearly had evidence showing that, well, this is really what's manipulating our data. Let's just assume that stand was the same, or our plant population was the same. How would that data work out? And now the one stipulation with that is that you need a significant correlation among every treatment. So if not all treatments are providing that correlation, you cannot do this transformation, right? So then this is a way to just visualize, say, all right, all 15 of my treatments are all negatively impacted, significantly impacted. I have evidence that I can move forward with these transformations. And other things. So maybe too much. Okay, perfect. Let's take a break. I'm going to pause recording here for a second. Okay, so welcome back. I am recording. I just hit record. Thank you, Sam. So we're now going to change gears, and we're going to talk a little bit about piping and creating tables. So two different things. Piping operators. So, with R, we've been using this plus sign. We're going to change that up a little bit differently when we're working with other packages. And we're also going to create tables. So once again, tables are just essential for presenting detailed data summaries, especially in research and data analysis. So I like to use the kableExtra package. So this really simplifies the creation of aesthetically pleasing and customizable tables, enhancing the presentation of summary statistics and other data. So built on that, there's this, so let me just go, you guys can go ahead and install packages. Jeez. Oops, I think it's lowercase kableExtra, capital E. Could not, packages. Okay, that worked. I'm just hiding that for future. KableExtra. Okay, so built in the backbone of this is actually the cable package. So once we're using kableExtra. So cable is just a function of the knit-r package, which is loaded in with tidyverse. So you kind of already have cable if you wanted. And that is primarily used for converting those data frames into a markdown or latex cable, something that you can bring into like the HTML format. It provides the cable function or cable argument provides basic functionality for formatting tables, such as aligning the columns and setting column names and then applying other basic formatting options. So kableExtra is just an extension of that package. So similar to how ggpubr is an extension of ggplot2, kableExtra is an extension of the cable package. And it provides additional customization options and formatting capabilities. So a lot of the arguments are just hidden in the background. So with cable, there's a lot of extra stuff you have to do, and it can get kind of confusing. So using kableExtra allows for more advanced customization of tables, making it suitable for creating publication quality tables with complex formatting requirements. So just to kind of show you right away, we can just do this cable, and we're just going to do assay. And now that's going to get put out in our viewer. And you can see that it lines everything into columns. So when we put this into Markdown, I'll let you guys, so KBL, and then we can just do our data frame, right? So I'm just going to show you this. In our Markdown, this is exactly what it'll pop out to be. So everything's there, but it's kind of hard to see.
How'd you open your Markdown?
Oh, I already had this done. But you can knit it if you want to knit everything right now. Hopefully it should all work.
I think I made everything.
Yeah, okay. Yeah, we don't have to do that. You see it. So once again, the difference between this plot, when we're in here, plots are, our figures. This viewer shows us what it will look like in an HTML format, right? So this is essentially what it will look like in our knitted document. So, that's fine and all, but I mean, like, it's kind of hard to see the columns and things like that. So, we're going to make some things, and I'm finally going to introduce this like piping operator. So piping is done by the shortcut there is Control-Shift-M. Let me M.
Is that 2 M's?
Shortcut Control-Shift-M. Does that work? Control-Shift-M? Yeah.
And that's the piping function?
Yes. So I don't know why, Darla, yours is so weird, or if anybody else's does that, but sometimes the piping operator can be a little bit different. The standard is this % greater than %. So this really just simplifies the process of performing multiple operations by passing the output of one function directly to another function. So essentially this chains everything together. It's kind of like our plus sign. However, the plus sign is adding layers, where this piping one is sequentially kind of doing it. It kind of does it all together. I guess maybe I shouldn't even say that. It is sequential, right? So it's going to create this table, and think of this as and then. So create a table, and then
No one.
what? Now we're going to add in this. So this is through the kableExtra package. So you can see kableExtra, Cable Classic. And actually, I'm just curious. Okay, so it kind of puts things out, changes our format a little bit, changes our text, creates a little bit of a header there, kind of formats it a little bit different. Here we can also do like HTML font equals, let's do Times New Roman. See if that works. There we go. So now we changed it to Times New Roman. Hopefully that works for you guys. Yeah? Okay, so you don't have to have the extra font package. That's awesome. So, now it's a little bit nicer. If you bring that in to your viewer, let's kind of go back here. This is the first one. You see how it's all kind of clumped together. That's just with the cable assay. And then when you say, and then Cable Classic, we get it a little bit spaced out, a little bit better to see. We can change the font and things like that. And there's one more that we can do. So this just uses, so once again, Cable Classic uses all these built-in Bootstrap themes by default. Default, that's the word I was looking for.
Yes.
Okay, Control-Shift-M. And then can do some more stuff. We can do cable styling. Here, we're gonna add in more bootstrap options. I like to do these ones. This is just my preference. We're gonna do hover. Condense. And responsive. Okay. So now it kind of sorted everything out. You kind of made it a little bit different. It allows you to hover over the top of it. Things like that. I really don't know what else. I think that was the hover and responsive part. So, it's kind of nice when you have a big bunch of tables and you want to go through on your arm markdown and make sure you're looking at, the full row of what you're looking for. So this is how I like to make tables. I found this to be the most aesthetically pleasing and the easiest to use. So a lot of times I am just copying and pasting this cable classic cable styling options. So we will be using that quite often as we move forward. Okay, Darla, are you doing okay?
I figured out how to change.
Oh, okay. Maybe she didn't want to change it. Is it not coming up?
Yeah. It says it right down here, but
You get library kableExtra loaded in.
yeah, it's just the last change, the bootstrapping options. I got it X out the line. I'm just trying to figure out where you're
Oh, you just don't have, you need your final closing parentheses.
Where does that wrap it back to though?
That's just so that should just be, yeah, in front of the bootstrap. So, make sure that you have your parentheses closed out. Error.
Unexpected symbol.
What? You spelled.
It worked fine before. The first function worked, it's not accepted in the other.
So.
Your keyboard is small.
It is. So a lot of tab options.
Did you use tab down that?
Yeah. You cannot type on this keyboard. I have no idea. I have no idea why. No, it shouldn't.
Why is yours is one notch longer?
Yeah. Yeah, there's no reason why yours should not work. I don't know what to tell you. I have no idea. Okay. So now that we kind of got that understanding, I'm going to change gears a little bit more again. Because, that's great that we can make tables, but what are we making tables of? So I'm going to bring in another package. Once again, this is just my preference. Maybe we can get a little bit more into other ways of doing this later on. But we're going to get our summary statistics now. So summary statistics just provide insights into the distribution of data. Excuse me. Such as the min, the max, the means, medians, interquartile ranges, anything like that. So I like to use this package, install packages, rstatix. This is once again my preference.
One and one package need to get updated or currently loaded. Restart it.
Oh. Yeah, just do yes.
It's gonna restart on.
Yep. Hopefully everything's okay and you can do your run chunks above.
Do we have to redo directly and all?
That's why, once again, so yeah, if there's things you have to restart or do something else. That's an important part about, making sure you have everything set up appropriately. And also, once again, I always do it in the top portion. Here, that way I can always scroll up to the top, make sure I have my packages loaded in.
Chunk 6, I can go back and use the link. Do they number all the chunks? Do you have to count them up? 1, 2, 3, 4, 5, 6, 7, 8, oh. Can you delete a chunk?
Yeah, you can delete it, or I would just highlight everything inside of it and do Control-Shift-C.
Control-Shift-C. Oh, yeah, makes it a note. Good beans. Let's try that. Warning messages up there. That's what we Hey, that might have worked.
What?
Working directly is still slow.
Okay. So once again, I really just want to emphasize that, what I'm trying to show you is just convenient ways, or, adding on some extra stuff. There's a lot of other ways to do this, but rstatix just provides a convenient way to compute various summary statistics, such as means, medians, standard deviations, things like that. I think you can also do some correlations and some extra stat stuff in here, but I usually use it just for the summary stats. So we can take our assay. We're going to pipe into get summary stats.
You want us to do this in that same chunk? We shouldn't be making.
Yeah, we can make a new chunk. Good point. Oops. And then we're going to do type. There's a lot of different types we can do. If you just do common, it's going to give you quite a bit. So you can see now it spat out this table. It said for all of our different variables, days after planting 6, we have 48 observations with the min, max, medium, interquartile range, mean, standard deviation, standard error, and confidence interval. That's great though. But if we end up, I'm just going to pop this over really quick. If we did that in our output or in our HTML, that's all that comes up. So once again, the table really isn't very clear. So, once we knit, this table won't look good once we knit our code. So let's see, let's use what we learned with kableExtra to make it better. Right? So once again, we're just going to pipe in, and like I mentioned, you can just go ahead and copy paste from the top there and add that right behind that. So we're saying take assay and then get summary stats and then create a whoops. Sorry, I messed up. You need cable. KBL. And since we're piping straight into this, we don't need to specify what is in our cable. Does that make sense? So if we look at what we did earlier, I'm saying cable assay. Now I'm changing it around. I'm saying assay and then create table, right? So I don't have anything in that parenthesis because we've already designated it beforehand.
You know that error I had that we couldn't figure out?
Yeah. Happened again? I don't know what to tell you.
I'm just gonna get rid of the bootstrap.
Okay, yeah, you don't have to have that bootstraps option. Let's just for conciseness, we'll take out that styling. All we need is just our cable classic makes it a little bit better to view. Oh, one other important thing here. So we do have a lot of digits here, right? There's no reason that we need to be having that come all the way out to 3 digits. That's actually in our cable here. We can designate digit equal 1. And now it will round everything to 1 digit. So before, with all of those, after adding digits equal 1.
I'm getting a bunch of errors. It won't let me do the digits equal.
Hmm. Oh, do you need to load in kableExtra again? Oh, double check to make sure you have your ticks, because like if let's say if I don't have that, I don't know, like it doesn't know that I'm in a chunk. Sometimes that happens. So now if I try to run that, it won't work. Always make sure you have your chunks closed out.
Yeah, I got it.
Just for a reference too, you should always see this down and up arrow. There was one time like Mike, you had boom, boom, boom. Like if I did this, now I don't think this will actually work. Oh, it still worked. Okay, never mind. That wasn't a good example. There was something like that that messed up somebody earlier on.
It must have been, I didn't have cable extract, and now I just redid, I copied and pasted what we did before.
Cool. Okay, let's keep going. So I'm just gonna keep adding on to this. So yeah, that's great. You know, we're getting data for everything, but what if I only want a few different variables, right? So sorry to do this to you guys. I'm just gonna enter this down. In get summary statistics, this is where we can add that combine. So C, let's say I just want total root rot index. I want AF root rot index, and I want rise. This is where I can designate what variables I want to look for. Oops, I need a comma. So let me just space that out so you can see a little bit better. Right, so I added in and get summary statistics. I only want these variables. There, so now we just have those total root rot index. So I am gonna fly through this. I am so sorry. Keep up if you can. Okay, we are going to now, because to get any further, right? Like this is nice because we get our total root rot index. But what if I wanted to get my total root rot index summary statistics for each treatment, soil, and year, right? So now we need to finally introduce dplyr a little bit more, and some of the statistical syntax provided. So, you know, this using dplyr, dplyr, and tidyr provide a set of functions for manipulating data frames, making it ideal for filtering, summarizing, and mutating, or even arranging data, right? So we are going to create a new chunk here. Ah, let's do that. Okay. And once again, we should already have dplyr loaded in through the tidyverse package. We're gonna go in. I will share this with you. So once again, when I send out my notes, this is what you guys will get. You'll get what group by filter rename does and all of these operators. So how to do equals, greater than, you know, some different things like that. What means and or not, they will be important. Okay, so we'll start off pretty simple. So we're gonna take our assay data. We're gonna pipe into group by. So right now I'm just gonna group by soil. And then we're also going to pipe into our get summary statistics. And just for sake of conciseness again, I'm only going to do total root rot index. And this time we're only going to do, I think I could just do it, mean standard error. Okay, and then we're gonna pipe that into, I'm just gonna steal this again. Ta-da. Okay, so just by that, now we've grouped by the climax and the pearly soil, just for total root rot index and just getting our mean and standard error. Crazy. The same.
Yeah.
Okay,
Summary stats.
and I just have just total root rot index this time. Okay, now let's say I'm just gonna go up in here. Let's say I want to do year. This is kind of where we're doing that, this other operator. So year and soil. So we're kind of looking at the interaction there. There. So now you can also see that we have year, soil, 2024 climax, and kind of those differences, or our summary stats as well. So the group by function is a part of dplyr, you know, that we have there. So what else do I have? Oh, yeah. So that's great. I am going to just keep adding on to this, and I'm going to add in our filter function beforehand. Let's say I only wanted to do just 2024, so I can say filter, and we're going to say year equals 2024. So if I did that, oops, there. Now it's only going to give me 2024 because that's all that we filtered by. You know, we can also change this. Soil treatment, right? So now we're only in 2024. I'm curious if this will even work. Yeah, there we go. So it's very important here is what this is saying is equal to 2024. You can very easily change this. Exclamation point equals, it says not equal to 2024. So if I run this, we should only get 2023 data. Right, so these are just different ways of filtering it out. And we'll get a little bit more advanced here in a second. Yeah, I have this one. So, you know, let's not only do that, we're gonna filter by year equal to 2024. And so we're gonna do the and symbol, and we're going to filter by treatment not equal to Sabina. Okay, so now we should only have our Tachagaran from 2024. You can also see by the number that we're doing, you know, that we're dropping out all of these different things. This is very powerful to be separating out your data this way. You know, I just want to also mention, like, if you wanted to create a new data frame, you know, we could just do, oh, no, why it does that. Assay 2023, we're going to make a new data frame based on assay by filtering year equals to 2023. Right. So now if we look inside up here, we should have our new one, assay 2023, half the amount of observations. So this is nice when you have a really big set of data. So, you know, Darla, maybe this would be for you with weather data. You have 10 years or 100 years of data, and you want to go through and just do 2023. That's your first step, because then you just make a brand new one with only 2023 data, right? And then you can do it again with January. You can do it at once as well. So I can do, once again, filter, year, and I wish if you had month, you could do months, but for me, yes. Thank you. Soil equals to time.
Why do you have two equal?
It's weird. You have to do two equal signs because the other ones that you can do would be like, sorry, I'm just gonna show just to show you. So equal is equals. Yeah, the exclamation point equal is not equals. We can do greater than, less than, greater than or equal to, things like that.
Time out.
Yeah.
I was noticing an error, I couldn't do soil and year. Right,
Okay,
so I just kind of skipped that.
do year and soil.
I tried that too.
I'm also having trouble with the group by.
So when I just
Hmm.
made that the 2023, and you said half, I only have 12 observations rather than 24. So that means I'm missing.
Did you do
year.
the end sign?
Yep.
No, that should be right. So if you do that, oh,
You have 12 observations.
I have 6. Oh, for assay? Which one are we on now? Yeah, so if I'm doing year end, like year 2023 end climax, I only have 12 observations from that.
So why wouldn't it let me bring in year when I group by year and soil? It just kept bringing up an error. The error is caused by error in year semicolon or colon soil.
Okay, so what I'm thinking,
So I'm just pulling in group by soil.
group by soil, let me just see.
You won't let me do soil and treatment.
I'm just gonna see dplyr. I don't know. Group by. Group by. Group by.
Is it my assay is not right?
No, your assay, so that's the thing, like usually we won't change that. Year and soil. Hmm. Oh yeah, you still have soil as a character. Go all the way up to the top. Maybe that would. So soil. So maybe that's why. Soil. Ta-da! Good job, Darla.
So it has not
Tried
changed.
this.
So that one's the assay 2023. So because now we got to redo that. So at the very top, when we brought in our original assay data.
Yep.
He did not have assay soil as factor. So, and you can also
Really
see that
good.
here, your soil is still a character and not a factor. So it doesn't know how to group by it. So that's the importance of, setting it as a factor, right? It's a distinct group. So I don't know if you heard that, Heidi. So are you able to use this, the group by function, when you have year, soil and treatment?
So I didn't hear everything, but yeah,
Are you having issues with this group by? Are you able to get this to work?
no, it's going fine.
Okay, perfect. So just to reiterate, it's very important is like when in your assay data, your year, soil and treatment have to be factors. They cannot be a character or numeric.
I wasn't even seeing that.
No, like, yeah, wow.
Okay. So once again, using this filter function can be extremely valuable. And then especially getting all of your summary statistics, right? So you can filter by year and then get summary statistics, so on and so forth. Awesome. Perfect. Let's see, where else do I want to go?
Where the heck is the end?
Okay, so I just have a bunch of us doing it. So I don't know if this is an appropriate time to do this, but
Why do you have an exclamation point?
it's saying not equal to.
Not.
Yeah, exclamation point says not equal to Kabina, and then we only get Tachagaran, right? So it's eliminating it.
I was about to have an error, but it.
Okay, actually, this is a really good point too. It's something I figured. So if I do this, I say, oh, how do I want to do that? I wish I had more.
Oh, I don't know.
So once again, this is all going sequentially. So just bear with me and try to understand this. So let's say I had 12 different treatments and I wanted to eliminate only 2 of them. I could do that. I could say treatment not equal to Kabina, right? And that would get rid of my Kabina. How did that work? And then if you try to use end not equal to again, sometimes you get an error because you've already previously removed an aspect of it. So another operator you can do is this control, straight up and down thingy. And that is or, right? So you can say year equal to 2024 or not equal to Kabina. Oops. So if we did this now, yeah, we get 6. So we get climax, Kabina, climax, Tachagaran, but only for, how does that even work? So 2023, we only get Tachagaran, right? So it's,
Oh, it's filtering by.
yeah. So we want all of 2024 or not Kabina. So, it's kind of hard to understand, like,
Can you do end on?
no. I mean, you can keep adding on. So if I wanted to keep doing this and then I wanted to say and soil equal to climax, right? So now it's either year equal to 2024 or treatment could be not equal to Kabina. Actually, it'd make more sense if that wasn't equal. No. There. So essentially it's saying all of 2024 or only climax and Kabina. Does that make sense? But once again, it's kind of confusing, but you can do a lot of filtering and adjustments and things like that just to look at specific treatment for yourself.
Treatments being back.
Yes. Yeah. Once again, I always assume that everything that is a distinct group is always a factor, right? So in our trials, your year would be a factor. Any type of treatment, so different locations, different soils, different treatments, and your reps. Those are all distinct groups within your treatment structure. I'm going to go through, I did a lot of like just sorting by different things, so you can do all these combinations. So, you can do all these different group bys, totaling, or we can do different strings. So let's say I wanted to also add in my AF root rod index, right? Now it's also going to add in, but it always does it, in the long format. Once again, so variable is in the long format. So I am just going to move that so you guys have it. So at this point, you see that in our one column, we have year, soil, and treatment all clumped together. Let's say I don't want that. So now I am going to say, and actually, let's say I want to drop out standard error and my number, right? It's just kind of superfluous, maybe. Maybe we just don't want to have that in our final table. We're going to take all of this and we're going to pipe in and we're going to use dplyr's select function. And I know that came up as something else. So we're going to say select. I want the column header, year, soil, treatment. I also want the variable and I only want mean. And oh, whoops. I'm so sorry. Let me start a new one because this doesn't know what to do. We don't want to do that first. So, once again, if we ran this chunk, so So sorry again. Okay, that's what I want. That's what I want. Okay, so I'm not making that cable yet. Everything is down here. So right, once again, I have year soil treatment. So you might be asking, well, you know, here I have these quotation marks. And why do I have those quotation marks and not for variable and mean, right? Look at your output down here. So year soil treatment has those quotation marks. I don't know why, but you need to match it up exactly. Okay, so then if I pipe into this, essentially it's going to just select only my year variable and mean. I dropped out the number column and also the standard error column. That's how you can select just the ones that you want. And now I want to make my select or my year soil treatment column into all individual columns, right? So this is another one. We're going to pipe directly into separate. And I want to separate my column titled year soil treatment into all separated year soil treatment based on the separator, the semicolon. Okay. So you can see in my, now it's dropped into, I have 3 distinct columns now, one for year, one for soil, one for treatment. Okay, and now we're going to do the exact opposite of what we've done in the past. Because now this is in the long format, but I don't like it in the long format. That's a weird, right? You don't, that's not how you read data in a table. So we're going to use the pivot wider function. So going to go on the other way. This is a little bit different. We're going to say names from variable, because we want the variables separated out. Variable values from, we're just going to do mean. See if that works. Yay. Did it work? Awesome. Okay. And then also just a little bit more about dplyr, whatever. We can also use this rename function. It's kind of nice. This just renames column headers. So like year soil treatment, let's say I want to do seed. It's weird, it's backwards. So seed treatment equals treatment. Right now it's going to make that as seed treatment. And then last but not least, I'm sorry, I'll go right back. Yeah, there we go. And then finally, we're going to add in our kableExtra, and that's going to put it off to our right-hand side here into a nice table. And even from here, you can go ahead, you can highlight everything, copy and paste, and then paste it right into Microsoft Word, as long as you have a table with the same amount of columns and rows, you can paste it directly in as just the numbers. Or you can actually export this and create, you know, a copy of this plot, but it will be an image that you can adjust later on. So. Okay. Yeah? Okay. I am going to just bear with me. I just want this just so you guys have it, or just so we talk about it when you get the recording or on my notes here, you'll get this information. So we're going to go a little bit further. Just bear with me. There's a lot more that we can do. So, you know, just this is what I mean. Just follow along if you can. Let's say we want to filter year just 2024. So I'm just kind of putting all this in together. We're gonna group by soil and treatment, because we're only looking at 2024. And we are going to get summary stats for total root rot index, staff root rot index, rot index. And we are going to get type equals, I just want mean and standard error again. Then I am going to say select, oops, because once again, I want to drop out that numbers column. I don't want that later on. Soil treatment, variable, mean and standard error. And now gets the fun part. So let me just make sure that's all working. Okay, so like you can see, I have mean and standard error, but what if I want that in the same table, right? And what if I want to round these off? These are all kind of weird rounding. You know, if we do that digits function, we're gonna round everything all together. But what if I want one column to be one digit and another column to be another digit? This is where it gets a little different, or I want standard error to be 2, right? So I'm gonna say mutate at the variable's mean, and I am going to use the function round, round, and this dot is just saying that I'm already calling mean, so I don't need to call it again. I want one digit. 1, 2, 3. Okay, I want to mutate at the variable standard error using the function round, and I want to do that one at 2 digits. Okay, the rounding. Yeah, we did the get summary stat. I'm just showing you this like rounding. Okay, now what I like to do is I can say mutate standard error. So I want to paste standard error. And once again, if you're having a hard time keeping up, I'll send this to you later. And you guys aren't going to have this. You can Google it. You can Google plus minus sign. I don't know how else to enter that. So I'm saying paste plus, or parentheses, open parentheses plus. Then I want to paste my standard error. So essentially what I'm doing here is putting my standard error within open and close brackets. And I'll just show you what this looks like. Okay, I'm getting a lot of errors or warning messages. So essentially what that did was round them all my mean to 1 digit here. And then I took my standard error, rounded it to the 2 digits, and then added in the plus minus and the parentheses. And now what you can do is take that information. I'm also going to select, oh, you can also do this, minus SE. That's going to drop, oh no, I'm one ahead. Don't do that yet. All right, now I'm going to mutate. I am going to take my mean, and I'm going to paste my mean and my new standard error column together, separator. And I'm just going to separate it by a space. Okay, and then I'm going to say select, drop my old standard error. So now, yeah, there we go. So now instead of having 2 distinct columns, I only have one for mean. Now this one column contains both my mean and my standard error within parentheses, and having that plus minus sign there as well. And then we can do what we had done before. We're going to separate. I cannot spell separate. Separate our columns, soil, treatment. And I'm sorry, I just wanted to at least get through this today into soil, treatment. Oh my goodness. I know, I'm so sorry. So, you know, we did this just a little bit earlier where we did that separator.
I just can do it.
And we're also gonna add in our pivot wider. And actually, I'm just gonna go ahead and paste that. It's just. So I've, you know, piped into my pivot wider and then finally did my cable. Boom, boom, boom. Ta-da. So that's how you get to your, you know, this is just 2024 data based on soil seed treatment, having all of our variables with our means and standard errors all together. So I know that was a lot to do, but once again, once you have this, you can copy and paste that information to make new and recurring tables. So yeah, this took me a while to figure out the first time, but it's helped me so much moving forward, right? So yeah, what are we at? 12 o'clock. All right. Yeah, I know. Okay, thanks for bearing with me, Heidi. That was pretty much it. Once again, I'll send out this video and all of my notes again. So if you want to practice this and actually see everything broken down step by step, make sure to just view that, download the HTML that I will send to everybody and view that on your own time. So hopefully it was nice. You know, just to recap, you know, we created a bar plot with labels. We created a box plot using the jitter function. We made a violin assay. We pivoted longer to make our stand data or to look at things over a time series and made that line graph. Made some scatter plots, looked at some correlation coefficients. We ended up bringing in kableExtra to make cables and rstatix to make summary tables. And then we learned a little bit more about dplyr, dplyr, to really wrangle our data, so data wrangling. So that's a recap. And I'll see you guys. I think Thursday might be a clunky day. We're going to go through some stats and some things like that as well. But that might be our final session. So I'm happy that we got as far as we did today. So, hey, see you, Heidi. I'm going to stop recording.
Thank you. Yep.